Okay, so we're in section 3.2, couple of theorems. So the part of calculus is we're given a theorem, we got to make a note of that theorem and see how it's used. Remember in the last section, we had the extreme value theorem. So we were saying that, if we know a function is continuous on a closed interval, it's got to have a max and a min. So that was the gist of that one. So these two theorems are very closely related. I would say really a Rolle's theorem is a special case of the mean value theorem. If you get one, you can get the other. So the best way to do it is just, I give you the definition, then we translate it to English out of the math language, and then we see how we use it, okay? So we'll get started with Rolle's theorem. So Rolle's theorem says this, that, and we're talking about a function. So given that a function f of x is continuous and differentiable on the open interval a to b. Because I can't say differentiable on the closed interval because you can't take the derivative at an endpoint. Okay, so it has to be on the open interval. But the function is continuous and differentiable. So continuous tells us on that interval that what does that mean if it's continuous?
There are no breaks.
No breaks. Differentiable means there's no what? If it's differentiable on the entire interval, there cannot be any breaks, and what else can there not be? Sharp turns. That means you can take the derivative on the whole interval. There can't be any sharp turns or any vertical tangent lines. Okay, so when we're talking about continuous, we just take a sidebar here. Continuous means what? No breaks. So that means, and differentiable also with that, if it is continuous, you have no sharp turns and no vertical tangent lines. So you can't have either one of those, okay? No breaks in the graph and no sharp turns. So if that's the case, all right, then what? Then, given that a function f is continuous and differentiable on the open interval a, b, then there exists, oh, hang on. Let's say one more thing. I'm doing mean value thing. Hang on. And f of a equals f of b. That's the other thing that has to happen. So that means the two endpoints, whatever they are at the same y value. So for instance, if I'm looking at a picture of this right now, here's A, here's B. We know that f of A and f of B are at the same height. Okay, so they're at the same height. So let me see. Would that be acceptable? Is it continuous? No. Are there any sharp turns? No. So this picture would fit this. Now here's what's guaranteed. So this is the key part. Then there exists at least one x equals c in AB such that f prime of c equals 0. So that's the magic there at the very end. Right? Yeah, we put that statement in and that gives us the magic. But we'll talk about what the magic here is. See if that makes sense. So, the key thing is, this has to be the start. The graph is continuous, no sharp turns, and the endpoints have to be at the same height. Now look at the slope between the two endpoints. If I were to make a secant line here, notice that between the two endpoints, what's the slope? Hopefully, my drawing is correct. 0, slope is 0. Here's what it's saying. Then there has to be at least one place in this interval where the tangent line, see, derivative is tangent line, that slope is 0. Well, for this picture, there's two. It's here and here. And what we're going to do is we're going to be finding those. We're going to be finding these locations. So on this problem, this would be my C1, and that would be my C2. There's two places. So f prime of, for that picture, we know that f prime of C1 equals 0 and f prime of C2 equals 0. And you're guaranteed, it is guaranteed that you will have at least one spot. It is impossible to go from here to here at the same height and you follow these two conditions and you don't get a slope of 0. It cannot happen. Okay? So whatever you want to do, I draw another picture and I say, okay, again, here's A, here's B, both endpoints are at the same height. I gotta go from here and I gotta end up here. All right? Well, if I go up, then I gotta come back down at some point. If I go down, I gotta come back up at some point. So there's gotta be at least one slope of 0. Okay? Even if I just go straight, then there's infinitely many points. But there's at least one, guaranteed. And that word, where is it? Did I use that word? Yeah, well, I didn't put guaranteed, but that, anytime you can stamp guaranteed on it in math, okay, we usually can't say that all the time. All right, so that's it. Now the question is, how are we gonna use that? Well, the first thing we'll have to do is when we're given a function, we gotta make sure, are our endpoints at the same height, and is the graph continuous and differentiable? If it's not, if one of those things, criteria is met, you can just say Rolle's theorem is not guaranteed, and you don't have to work the problem, okay? So here's an example of where we gotta do a little work on our own. So the first thing that on example 1 says, it says find the two x-intercepts, okay? So we're just doing pre-calc. We're kind of doing some of the work for them here. I'm gonna erase this. I'm going to leave Rolle's theorem up as we use Rolle's theorem to work example 1. So the first thing we're asked to do is find the x-intercepts. And then show that f prime of x equals 0 between the two x-intercepts. Find that spot. So first thing we're going to do is how do we find the x-intercepts for this function? We have to set it equal to what? 0. So go ahead, set it equal to 0. I would probably factor out a negative and go from there and see if you can get the two x-intercepts in a matter of, seconds. I think you can work this fairly quickly. Okay, so I would have factored a negative out, and then I'm left with minus 3x minus 28. So I'm looking for two numbers that multiply to give negative 28, add to give negative 3. What would that be?
7.
I got minus 7 and plus 4.
Yeah.
Sure, I didn't do that. But your solutions will be 7 and negative 4, right? Yeah, when I factor, it's x minus 7, x plus 4. Set each factor equal to 0, we get 7 and negative 4. So at 7 and negative 4, those should be the x-intercepts. So these are the 2 points these are our endpoints. So what this is talking about is find the two x-intercepts. Okay. So I've got the two x-intercepts, -4 and 7. Here's this. All right, now, so this is like my A and my B. These are my endpoints, okay? Then what do we know? Here's our function. Well, we know a lot about this function, right? I mean, it's a quadratic, so is a quadratic continuous? Does a quadratic have any sharp turns?
No.
There you go. You know that since that's a negative in front, it opens down like that. You really don't need calculus for this one, but we'll just do it. So now we've got to set the derivative equal to 0, and we're going to find the x's where the slope is 0. Well, you can see there's only one spot, right here, wherever that spot is, right? We're going to find that x. Where is the slope equal to 0? So your process is first, in between these 2 points, there should be one x. Okay? So my next step so now what do? I'm looking for f prime of what gives me 0. So I'm going to find my derivative. So I'm going to find f prime of x is -2x plus 3. And I'm going to set it equal to 0. So this is what you'll be doing to show that Rolle's theorem is true. Okay? And then I'll solve for x. -2x is -3. X is -3 halves. I'm sorry, -3 over -2. So x is 3 halves. And is 3 halves between -4 and 7? Yes. And that's the guarantee. Okay. And that's Rolle's theorem. All right. Let's do another one that we'll do one similar where you got to find the x-intercepts first. And I'll do this. We'll crank up the difficulty so it's not such a because this is kind of an easy problem. But that's really it. So sometimes they're going to have you find the 2 endpoints. Sometimes they'll give you the 2 endpoints, and then we've got to verify that they're at the same height. But I know x-intercepts are at the same height. They're both. Are those 2 at the same level? That's what this is saying. Okay. All right. So just erase this function. I'm going to put example 2. I'm going to give you a new function. All right. So now we'll see given f of x is x square root of x plus 4. And let me give you a hint. It's already factored. There's 2 x-intercepts. Okay. This function is already factored, and there's 2 x-intercepts. That should help you. Okay, so let's at least make sure we got the we know what our boundaries are that we're going to be looking at. So first thing I'm going to find are the x-intercepts. The way I find x-intercepts is I set the function equal to 0. So notice we're setting the function to 0 to get x-intercepts, then we're setting the derivative to 0. Well, all I've got to do is already factored because this is multiplication. So I said each part equal to 0 and solve. And you should get 0 and you should get what else? -4. So this graph, so now how do you know that it's differentiable? Well, think about a square root. Square root's not gonna have a sharp turn with it. This is an x times a square root. This graph is differentiable from -4 to 0. So we're looking now, in this region. Now, the only reason I'm graphing it is because I want you to see the picture, but from here to here, that's not 0. That's 0. So somewhere between -4 and 0, there has to be a horizontal tangent. We're gonna find, okay? So now we're looking in here. So our interval is between -4 to 0. That's all we're finding. So in between there, the graph has to either go up and then come down, or go down and come back up at least once, okay? We're gonna find where that valley or that hill is. So now, what's the process? Find, so here, once we're here, this is it, this is your step. There's at least one x equals c such that f prime of that c is 0. So we're gonna find f prime of x instead equals 0. You got a little work. So here's my advice to you when you go and do derivative. Make f prime of x into one fraction. That's going to help you when you're trying to figure out what makes it 0. Okay? Make your derivative in, I mean, that's what I would do, but there's going to be a little work there. So we'll do one more, and then I'm going to stop. So that'll be Rolle's theorem. And then we'll do another. Because I think if we do 2 videos, it'd be better. We'll do Rolle's theorem, and then we'll do mean value theorem. All right, so I'm just going to work through this one just for the sake of saving some time. So if I'm going to find this derivative, well, it's something times something, so I've got to use what rule? The product rule. So I know it's going to be u prime b plus b prime u. All right, so I'm going to go over here to the side. If u is x, and u prime is what? 1. B is square root of x plus 4. Do you remember the shortcut for square root? Yep, 1 over 2, square root of x plus 4. And then you're supposed to do chain rule, which means you would multiply by the derivative of the inside, which is 1. So that's nice. So you don't need to worry about that. Okay, so let's see what we got. U prime is 1. V square root of x plus 4. Plus v prime 1 over 2 square root of x plus 4 times u, which is x. Okay. And remember, we're supposed to set this equal to 0. But remember what my hint was to you. Anytime I'm doing derivative, if I get, say here, I have separate fractions, I would just get a common denominator and make it one fraction. So technically, this first part is over 1. This second part is over 2 square root of x plus 4. So you can see what your common denominator is. All right, so I'm kind of running out of room a little bit. But what I'm going to do is I'm going to multiply this first fraction, and we don't need this one. I mean, you can see that u prime is 1. So I'm going to multiply by 2 square root of x plus 4 over 2 square root of x plus 4. Okay? Let's see what we get. So the numerator becomes, running out of room a little bit, becomes this, 2 times the quantity x plus 4. So notice, by me getting a common denominator, I canceled that square root that was in the top, okay? Don't forget plus the x that was on this numerator over 2 square root of x plus 4. And the only way that a fraction can equal 0 is if what part equals 0? How can a fraction, this divided by this, the answer is 0? What part has to be 0? The top. Because the bottom, we already know that's an endpoint, okay? So we're going to set the top to 0. Well, this is 2x plus 8 plus x, which is all that right there just becomes 3x plus 8. So this we're gonna set equal to 0, so we have 3x plus 8 is 0, and so we get x is negative 8/3. So we are saying that f prime of negative 8/3 should equal to 0, and negative 8/3 is in between those two. Okay. All right, I'm going to erase the Rolle's theorem and we'll do one more. All right, so this will be in the video. I'll send it at the end, so if you want to go back through these steps. All right, so erase the theorem that's here. All right, one more problem. Last one, example 3. Now let's do it shape 1. And we'll do f of x equals x minus 4 times x plus 2 squared. And we're on the interval negative 2 to 4. All right. And the first thing is, so can Rolle's theorem be applied? Is it guaranteed for this interval negative 2 to 4? If so, find the x values guaranteed. So, first question, what type of graph is this? Yes, polynomial. If you multiplied it all out, it'd be an x cubed, so it's a polynomial. Are polynomials everywhere continuous? Yes, so you know it's continuous. Do polynomials have sharp turns? No. So one thing I would encourage you is if you go back into your pre-cal notes, there's 5 or 6 characteristics of polynomials. Be good to review that. Now, we got to see if the endpoints are at the same level. So f of negative 2 has to equal to f of 4. If not, if we're not at the same height there, then we're not guaranteed to have a slope of 0. But if they're at the same height, whatever they are, then the slope is 0. Well, look, if I plug in a negative 2, what do I get? Plug it into the second part. 0, because this is 0. If I plug in a 4, what do I get? So those are x-intercepts. See, negative 2 and 4, which is fine. All we care is that they're at the same height. Okay? At the same y right there. Then, what are we looking for? Well, there has to be an x in there. So now you got to take the derivative of this. What rule probably are you going to do if you're going to leave it like this? What rule do we use when two? Yeah, product rule. All right. So first thing I did is I found the endpoints. Make sure they're at the same height. So yes. So the answer to part A is yes, it can be applied since f of negative 2 equals f of 4. And I know that polynomials are everywhere continuous and differentiable. All right. If so, find the x values guaranteed. So now you got to do the calculus. Okay, so I've set up product rule, I found my U prime and my V prime, I'm gonna go ahead and sub in, catch up to you and see if we're in the same spot. So I got U prime is 1, V is x plus 2 squared, plus V prime is 2 times x plus 2, and U is x minus 4. Now, I wouldn't multiply that out, because I can see I have a group 1 and a group 2 here, separated by this plus. I can see in common each group has at least an x plus 2. So if I factor in, because the easiest way for me to solve is factoring. So I can take out, let's make sure it's showing up here. I can take out an x plus 2. So the way I'm going to solve this is I'm going to take an x plus 2 out of each group, and that will leave me in this first group with what? Just one x plus 2, right? Because it was squared. And then in the second group, I'm going to be left with what? So look, guys, this is one group here. This is another group. Each one has at least an x plus 2. So if I factor this out, which is the reverse of distribution, what am I left with in the second group? 2 times x minus 4. I mean, it goes a lot better if you guys can answer, rather than, otherwise I'll just talk to the screen the whole time. All right, and then if I multiply and combine there, so now what am I left with here? I have x plus 2 plus 2x minus 8. I have 3x plus 2 minus 8 is minus 6. Make sure I didn't do that wrong. X plus 2, 2x minus 8. Yeah. All right, there's that. Set each part equal to 0. I'll set x plus 2 equal to 0 and 3x minus 6 equal to 0 because it's factored. And I get x is negative 2 and x is 2. Okay, now you got to be careful. One of these answers you don't take. Anybody know what answer I do not take? You don't give both of these. If you give both, you're wrong. Read the Rolle's theorem. What does Rolle's theorem say? Just read it from the start. Eli, read it out loud for us.
Given that a function f of x is continuous and differentiable on open interval.
On the open interval a to b, which is in this case negative 2 to 4. All right? Yeah. Go to the asterisk. Then there exists anybody where the asterisk is, the most important part of Rolle's theorem. What does it say? In AB. In. Not on the end. In AB. AB, you don't include A and B. See, negative 2 is an endpoint. You can't give it because it's an endpoint. You got to give it, it's got to be in the interval, not on the end. Your only answer is 2. See, negative 2 is an endpoint. So your only answer is 2. Be careful. That will cost you on your assessment. All right. I really don't feel like starting and stopping, so we're just going to keep going. Mean value theorem. If you can do Rolle's theorem, you can do mean value theorem. And actually, mean value theorem is the broader theorem. For me, Rolle's theorem is a particular example of mean value theorem. So let's do mean value theorem real quick. It's good. The definition is going to go pretty much the same. All right. So here's what we got. Mean value theorem. If f of x is continuous and differentiable on the closed or on the interval a to b. You get the interval from a to b. So it starts off the same way. It's got to be continuous and differentiable. And you have the endpoints. And f of a and f of b exist. So you have the endpoints there. But they don't have to be at the same level. Okay, so this is the difference here. Your endpoints don't have to be at the same level. Then there exists at least one x equals c in AB such that f prime of c, and it's not going to equal to 0 because those endpoints are not at the same height. So if I look at my picture here, here's A, f of A, say this is B, f of B. So there's f of A, there's f of B. So this could be my picture, okay? And let's say this is my graph. My graph is doing this, all right? Let's just say that's the picture that we have. So what is guaranteed? Well, like before, I drew a line between the two endpoints and we looked at the slope. Well, in Rolle's theorem, since they were at the same height, the slope between these two was 0. So the slope between the two endpoints, we can find that. That's just normal slope. That's just changing y, we're changing x. So if we have the two endpoints, we can see that the slope of this green secant line is f of b minus f of a over b minus a. This is just normal slope, okay, from here to here. Well, here's what's guaranteed. There has to be at least one tangent line with the same slope. So if you just tilt it like this, see, if you tilt your head, this is what Rolle's theorem was. That was at the same height, and we were finding the slope of 0. So it's like Rolle's theorem is tilted. It's the same idea. So there has to be, so basically, we're going to have to find the slope between the two endpoints, and we got to set our derivative equal to this slope, not equal to 0. Okay? So then there exists at least one x equals c in AB such that the derivative is equal to f of b minus f of a over b minus a. And I like to put that the slope of tangent is equal to the slope of the secant line. There has to be at least one spot that happens. And that's the mean value theorem. So it's very similar to what you're doing with Rolle's theorem. You just got to find, you don't set it equal to 0. Okay? Unless those two endpoints were at the same height, then your slope would be 0. Okay? So we'll do one. It's very similar. Okay, let's see here. Let's apply the mean value theorem. Okay. So given, I think this is example 4, given f of x is 2x cubed on the interval from 0 to 6. First of all, can MBT be applied? Part B, if so, find any x values guaranteed by the mean value theorem. So let's look at my function. Is 2x cubed continuous? Is it differentiable? Yeah. So now the difference is this. I'm going to take a second and find slope between these 2 points. So I'm going to find the slope of my secant line, which is going to be f of 6 minus f of 0 over 6 minus 0. So I'm going to take 2 seconds and do that. I'm going to see what the slope of the secant line is, because I can see that this graph does something like this, and I'm going to go from 0 to 6, and I'm going to find the slope of that secant line. Now, if I just look at this picture here, how many places do you think on this curve that are going to have the same slope as a secant line? How many answers do you think there's going to be? So along this curve, here's the slope of the secant line. How many places do you think the tangent line is going to be equal to that? How many are guaranteed? At least how many? But it is exactly 1. It's only going to be 1 spot. Okay? All right. So real quick, we'll plug in and we'll figure out what this slope is from 0 to 6. So we'll plug into the function. 2 times 6 cubed minus 0. If I plug in a 0, I get 0 over 6 times 0. And it looks like, or sorry, 6 minus 0, it looks like you get 72. I got a slope of 72. 2 times 36. make sure I did that right. So the difference now is you're not setting your derivative equal to 0. You're trying to figure out this slope is 72. So where along this curve is there a slope of 72? That's what we're trying to find. Okay? Between 0 and 6. Okay? Everybody see how I got 72? 2 times. You understand I'm just doing slope, right?
Right.
Okay? I gotta find changing y over changing x. You good with that? So when I plug in a 6, it's 2 times 6 cubed. When I plug in a 0, it's 0. There's my y's, there's my x's, all right? So look, I have 2 times 6 cubed over 6. 6 cancels. Leaves a 6 squared. 2 times 6 squared, 2 times 36, 32. Okay. All right, now what do? I take f prime of x, and I'm going to set it equal to 72, not 0. This is the difference. So I like to go ahead and set up. This is what I've got to solve. So I'm going to see where is the slope of the tangent line the same as 72. So you need to take your derivative of this, set it equal to 72, and solve. You should get 2 answers, but there's only one answer you keep. All right, so derivative is 6x squared. I set it equal to 72. I'm going to divide both sides by 6. What's 72 divided by 6? 12. Then I'm going to do square root of both sides, plus or minus the square root of 12. Well, that's plus or minus 2 on the square root of 3. But I can't keep both of those answers. Again, this would be a mistake. What's the only answer I keep? Remember, I'm looking between 0 and 6, so I keep the positive one. And that's the answer. So at 2 square root of 3, wherever that is, the slope of that tangent is the same as the slope of this secant. And that's the mean value thing. So the extra step you got to do on mean value theorem is you've got to find the slope between the 2 endpoints, and that's what you set your derivative to. Notice that's what we're saying here. Take your derivative, set it to the slope between the 2 endpoints, slope of the secant line. Okay? Real quick, one more, and this will be a fast one. Example 5. Given f of x is 1 over x minus 2 on the interval from 0 to 5, part A, can MVT be applied? Part B, if not, state why. Well, I'm helping you on this one. So what's the problem with the function there? Anybody see it?
Yeah, keep looking at 2, which is inside the interval.
Yeah. So it's discontinuous at 2. See, that's a vertical asymptote. So the answer to part A, no. Part B, why? Because f of x is discontinuous at x equals to 2, which is in 0 to 5, like Graham said. So be prepared that you don't always work every problem. Okay? So Rolle's theorem, this is a summation. F prime of x is set equal to what? Rolle's theorem. The way I remembered it when I was a kid, Rolle's got an O in it. Mean value theorem, f prime of x is set equal to what? Slope of the secant line, that, f of b minus f of a over b minus a. You got to set your derivative equal to the slope between the 2 endpoints, okay? And that's it, then you're solving for those x's. And remember, your answers have to be in the interval. There you go.